So we've just seen that we can use what's called automated machine learning or auto ML to develop a model and just basically point it at the data. The data is properly labeled and it can go off and do its work. Now we want to still remain within the no code machine learning set, but we want to have some more control over it. We want to examine the data. We want to build the steps. And so the option for that is called the Azure ML Designer. So it is one of the ways that you can build a model within Microsoft machine learning. So this is considered a no-code approach, like the automated ML. So you're not actually writing any code, you're just building the model. For example, we're going to see this in a second. I'll do a live demo with the ML Designer just like I did with the Auto ML. But you can drag your data set onto the canvas. You can examine the data, visualize it, see histograms of each column, how evenly distributed the data is. You know, there's various things that you need to do to make sure your data is in a good state to use in terms of a machine learning algorithm. You can exclude columns if you know that this column is not going to positively impact your results. You can basically set that to exclude. You can go row by row and say exclude rows that don't have values for this. So if your date of birth field, for instance, is a primary field in terms of you building your model, and you do have some data that does not have a date of birth, you can just sort of exclude it from the model. Now keep in mind when you're doing this that this is going to affect the quality of your model in the end result. So if you exclude anyone who has no date of birth on file, then your model isn't going to work for people in the future in a production setting when you don't have the date of birth. So excluding data is always going to affect the outcome. There's also a step called normalization, which we'll see. Basically, it's going to make columns more standardized. You might have some columns that are a value from 0 to 1 with various decimals in between, some columns that are minus 50 to positive 50, some columns which are 1 to 90, and you basically put them on the same range. Let's say it's 1 to 100, and that makes it easier for the model to evaluate those features and how they relate to the label at the end. And as you've made your data, you've normalized your data, and then you're going to basically pick the model. You have dozens of models to choose from. You're going to pick the model you want to try. So unlike the automated machine learning, you are going to basically be the one to pick the model. Here's an example, and we'll do a live example in a second, but a screenshot example where we can see at the top the automobile data, a number of steps, selecting the columns, cleaning the data, normalizing the data. As we go down the right side of the image, you split the data into training and evaluation. You've chosen, in this case, the linear regression model to run against that data to do the prediction in a regression model. And at the end, you're going to have to evaluate whether this is a pass or a fail. So we're going to pause the video now, and in the next video, we're going to demonstrate this live within the Azure ML Designer. So like I said, we're going to use the ML Designer instead of using automated ML in this example. Now I'm going to assume I already have the ML workspace created, and we're going to get into creating a brand new pipeline. We'll choose a blank one as opposed to one of the pre-defined ones. Now the first thing we need to do is we need to point our blank pipeline at the cluster of computers, which I'll do there. And we need to get the data set. So I'm going to choose the automobile data, the same as in the previous video's screenshot. And what we can do is then we can visualize the data. If we go right click and say visualize, we can see the contents of that data. Again, this is a sample data set. You could obviously create your own data set if you've got data sources. So we can see in this sort of frame on screen, we can look down the data columns and we can see the distribution of values. So some of them have a normal looking bell curve, and some of them are quite concentrated on one end of the spectrum or the other. Now price is the column that we want to predict. So I can click on the price column, I can see more details about it, I can see the visualization between the minimum, the maximum. A lot of cheaper vehicles in this data set and the more expensive vehicles are not. The first thing we need to do is drag the select columns in data set. So we've got the raw data and we need to know which pieces of data we want to pull from that. So we can go under here. Again, it's all drag and drop. There's no coding. Go under here and we can start to choose column names. Also I'll say edit column and by name. And I'll go and basically I want all columns, but what I don't want is the normalized losses column. So I'll choose every column for this except for that one column in this particular example. Of course, this is the science of data engineering, where you're going to have to choose which columns. Now the data set we chose does require to be cleaned. It actually said it in the description that cleaning is required. So I'm going to put the clean data set rule there. And we're going to then choose which columns we need to clean. And there's quite a number of them, so we'll select them one by one. And we can say we want to actually remove rows that don't have a value. So in those columns, the values are between 0 and 1. And if they don't fall in that, we can just remove it. Now you'll see the clean missing data has two outputs. We're going to choose the ones that have been cleaned, and we're going to connect it to a normalization step. Now, as I said in the previous video, normalization is the process of rescaling a set of numeric values. So if you have columns that go from negative to positive, you can basically set all of those columns up on a constant scale. So that makes them comparable and easier to work with. Now, I've said in the past that these videos are not intended for you to follow along, more for you to sort of experience what it's like to build a model in this quote-unquote no-code style of model development. You're not going to be required to be able to do this in order for this exam. This is more like getting a sense of how it is. So now we've got this step. We've got our data involved. We are going to basically clean the data, normalize the data. We could basically set the model off and tell it to go run on that data to get to a point where we can use the data. Now, you don't have to do this at this stage, but this is sort of a good reality check where you can get your data transformed and then examine the data after it's been transformed. Now we can see on screen that the boxes have turned green and it's had the word completed. And so we can see that there is a transformed data set under outputs. We can actually visualize the result. So remember, we visualized the input a few minutes ago, and now we're visualizing the output. And one of the things you might notice is that these columns like bore and stroke and horsepower, they've all been normalized, so they're on this scale of 0 to 1. So whatever the original values were have been mapped to a normalized scale. Now it's time to divide this data up between the training. training data and the testing data. So we've said in this course that there basically ends up being two sets of data, one to generate the model and one to test the model. And so this split data method is basically what's going to split this into two sets. You can see that I am saying that the 70% of the data goes in the training set and 30% goes into the testing set in this setting. So you can set that. I also gave it a seed so that it randomly selects the data in a more unique way. Now we're getting into the meat of it. We're going to train the model. So we're going to take the training data, which is the left channel here, and move that into the training set. Now this is where we have to select which of the data columns we want to generate the prediction on. So that's called the label. And so we want to get the price column to be identified as the label. So we'll go under here and just pick the price column, which is the last column. Now we do have to choose the machine learning model. So if we go under the models, we can see them. I can enter regression in the search, and we can see there's lots of, fast forest and multi-class and neural network. We're just going to choose linear regression. It's a classic model. Now obviously we have to then run the model that's been trained against the test data, which is the right dot on that split data, and that will evaluate how close or far it is. So let's submit that and let that run to see how that runs. So hopefully this video has shown you that you can use the Azure ML Designer to manually build a model still in the no code set, but you have much more control over the steps and the properties and the parameters and the decisions that are being made in order to find the model. Now you might have to run this several times in order to find the best model, but it basically gives you more control than the automated way. So the remaining sections of the course deal with common workloads within Azure ML. This section of the course talks about computer vision workloads and is worth 15 to 20% of the exam score. We can see on screen the requirements of the exam. First we'll be talking about a lot of the use cases for computer vision, and next we'll be talking about the specific Azure services that can be used for those tasks. So let's talk about when you would consider using a computer vision type service. Now one service in Azure is called image classification. So you are able to feed an image to that service, and it will come back with a single term telling you what it identifies from that image. Now there are pre-built models for this, or you can actually train your own model for image classification. The next computer vision task can be called object detection. This is an interesting task in that it can identify multiple objects present in an image. It will not only tell you its best guess in terms of what it is, but also locate it for you. So there will be a rectangle and X and Y coordinates that will tell you where the objects exist in the image. And in the screen we can see it found a maple leaf in the ground. And it can also be more complicated. You've got a bicycle leaning against a tree, some text on the screen, and it can find the bicycle wheel, another one for wheel, the bicycle itself, and there are individual rectangles for each object it can identify. Again, there's also confidence scores associated with that. So that is the object detection, is identifying and locating multiple objects within an image. The next thing a computer vision service can do is called semantic segmentation. And this is basically identifying the boundaries of objects. And so instead of, you pass a satellite image of a number of houses, then you end up with basically a drawing of where those houses are located on the edges. Now you can imagine this can be good for self-driving cars and any type of thing that needs to understand the edges of things in a picture. The next computer vision task that Azure can support is called optical character recognition. It's pretty straightforward. It can basically read text on an image, and so you see on screen we have our bicycle image, and on the right it's able to extract the actual text from that image. That could be useful for a lot of situations. Next up we have what could be a controversial feature, which is facial detection and facial recognition. So you can see that this, you upload an image of Tom Cruise, and the Azure Machine Learning is able to identify that it is Tom Cruise. Not only that, it gives the description as being Tom Cruise wearing a suit and tie, smiling and looking at the camera. Well, he's not wearing a tie, but other than that, it's pretty accurate, giving it a 97% confidence to itself. And so this can be considered facial recognition. You can see the blue box on the image identifying the area that is the human face. So now that we've seen some of the capabilities, let's talk about the tools. So for computer vision specifically in Microsoft Azure, you have two services that are options. One is called the Computer Vision Service, and the other is called Azure Cognitive Services. So if you ever choose Azure Cognitive Services, it's almost like an umbrella service. It gives you a single endpoint, and it gives you a single key, and you can access all of the cognitive services using that single URL. If you start using the computer vision service and then you want to start using the natural language processing, those would be separate URLs if you don't use cognitive services. Now let's talk about the computer vision service. Now the computer vision service is a pre-trained machine learning model. So if you feed an image to it, it's already ready to go, and it can identify over 10,000 objects. We saw some examples of that in the last video, where it identified the leaf, it identified the wheels, the bicycle, etc. It has features that allow you to generate captions for images, tags, descriptions, etc. It also supports content moderation, so you can basically block adult, racy, or gory content from ever being posted to your site if you run those images through the computer vision service first before allowing things to be posted. We saw in the last video the ability to detect faces, and it's a very robust set of services around face detection and also text recognition for written text in an image. Now there is an alternate service called the Custom Vision Service. So we had the Computer Vision Service, and now we're talking about the Custom Vision Service. This is a model that you yourself can build and train. You upload a number of source images and you label them, give them tags, and then you can use other images to run against that, and it can do classification or even object detection. And once you're satisfied with that, you can publish the model so that others can use it. I'm going to demonstrate both of these, the Computer Vision Service as well as the Custom Vision Service, after this video. Now what we'll see is when we create a custom vision, they do separate out the training of the vision into the two. Training and prediction become two separate resources, and we'll see that. Now another type of computer vision is called the face service. So remember, we said cognitive services is an umbrella across all of this. Underneath that you've got computer vision, custom vision, and now face service. So face service is what recognizes the human faces in images. It actually does, just like object detection, return rectangle coordinate vision, and now faces. Now resources, and we'll see that. Now another type of computer vision is called the face service. So remember, we said cognitive services is an umbrella across all of this. Underneath that you've got computer vision, custom vision, and now face service. So face service is what recognizes the human faces in images. It actually does, just like object detection, return rectangle coordinates of multiple faces that appear in an image. It can recognize celebrities, And so it's been pre-trained on your favorite Hollywood stars. And if you want to use this in your application, let's say for your employees or for your customers or for whatever purpose, then it will need to be trained on your own data. Now, we said at the beginning of this course, way at the beginning, about the principles of AI. You have to be careful. Facial recognition is a very touchy topic. There was a company here in Canada that was installing cameras in shopping malls and would use it. Maybe it's for not a nefarious purpose. It was just detecting the genders and ages of its shoppers, but it didn't mention this at all, and it was a bit hidden. The camera was hidden in these mall maps, and so you couldn't really see it. So you have to be careful to make sure you're doing it ethically. In addition, Microsoft Azure makes sure that you certify that you're not part of a police department or government agency to use this. They're very sensitive to the use of facial recognition by the governments. So let's look at some examples of face detection. So we have here the ability to detect gender, approximation of age. That's called face detection. Another service in that is called face verification. So you may have a database of known people, maybe it's your employees, and it's going to compare the face of an unknown image to the database of your known faces and identify who a person is. So you could use this as some type of security or other model. It does have a feature called similar faces, and so as opposed to identifying who the person is, you can identify faces that are similar to that person. And we can see here that in the model on the left, she is also the same model for the first and second picture out of the 5 pictures that we know. So you can identify similar faces. Another feature of the face service is called facial grouping. So you send a set of unknown faces into the service, and it will group them into people who are likely the same person. And it can also further divide those sets based on their facial expression, such as when they're smiling or they've got a flat expression, etc. There's some features of that. The last facial service we'll talk about is being able to, it's called the Identify API, and you're basically able to put a name to a picture. So if you have already trained the model to recognize certain people, then it sees a new picture, it will know that that is Bill and that is Anna, etc. Another Azure service for that's basically a computer vision service is called Form Recognizer. And so you can then upload, usually this is done for images, but it's for forms, for invoices, and it will basically be able to identify the various fields on these standard forms and extract the data. So we take an image of an invoice on the left, it turns it into a JSON data set on the right. So it's ideal for standardized invoices and receipts. There is a pre-built model. You can also train your own model if you've got forms that you standardly use. Again, it pre-recognizes the common receipts and invoices in North America, especially in English in the United States. So let's get into demoing a couple of these services. So in this video, we're going to do a demo of the computer vision service. Now, I will warn you that we're going to switch into sort of a code mode here. We've done the demo of the automated machine learning and the designer. And so we're going to switch into what is called a Jupyter Notebook and start doing some stuff in there. Now, I don't expect you to follow along. I'm going to do a copy from the Microsoft Docs GitHub repository to download their code and their examples. So you can see that I did the git clone command inside of a Jupyter Notebook in order to get that code. What it's doing is it's downloading this into the computer instance that we have to support our Jupyter Notebook. Now, I can now hit refresh and I can see that the files exist right within the Jupyter Notebook there. Okay. Now there is some existing code that I can go into. You can see under the code samples, we can just open the Python script. It's got a very clever set of documentation in there, and so if you do want to learn this to a deeper level, if you're going for AI 102 or one of the advanced AI certifications, this might be something that you play with. Now you can see what it's asking us to do is to create a cognitive services. So remember I said that you can have the computer vision service, or you can have a cognitive services as an umbrella service. So I'm going to go into the marketplace, search for cognitive services, create it. I will create one kind of quickly here. It's really easy to create anyways. So I'm going to put it into my resource group, put it into West US region, give it a name. There is a standard S0 tier. I do have to certify that I'm not working for a police service, and hit create. Now the purpose of creating this service is so that we can get what are called the keys and the endpoint. So I can show the key, copy the key, go into the code, place my key into the code, and grab the endpoint for my cognitive services. And if I click the run cell, then the notebook is going to put those strings and do a print. It's not really doing much other than setting that into variable. Now we do need to install the Azure Cognitive Services package into Python, and so clicking this pip install command downloads that and runs that. And basically now we're ready to go. So we do have some code. Like I said, it's not supposed to be something you follow with, but it's going to take an image and it's going to upload it to the pre-built computer vision service. So I'm not training a model already exists. So I'm uploaded this store cam, this woman with a phone taking a picture of a child, looks like, and you can see that it's generated a description called a woman holding a phone. So that's pretty accurate, and you can see there's some Python command in order to generate that. And then we're going to run it again for another store cam 2, so a different image. If I click run, again 2.4 seconds, it says a person holding a cell phone. Very similar, but it's got a lower confidence score. Now there's a lot of people here, they're shopping, there's some action, so caption is still not wrong. And finally we're going to go back to the original store cam picture, but we're going to ask for description tags, whether it's adult content, to identify any objects and any faces. And we can see sort of a confluence of boxes that shows us the adult is false, racy false, gory false, identify all the objects in the picture, and identify the face, person age 32. So that's all pretty cool and actually not that difficult. So in the last video, we looked at the computer vision service, where you have some pre-built model. You can just provide some images and get the objects out of that. In the custom vision service, you're the one training the model. So I'm just going to create the custom vision service here real quick. And you can see there is a free tier for this, so if we don't want to have to pay, you can do only 2 transactions per second, and that's in the free tier. Alright, so our custom vision service has been created. There is a URL called customvision.ai, which is going to be used for this. You go there to log in. We're going to create a new project. So this is going to be a set of images that I'm going to upload. Now you're going to say it's a classification project, that there is a multiple tags per image, and maybe you want to precede some of this. We're going to do landmarks in this one, so I'm going to choose the landmark set of knowledge. So I've uploaded some images here. I've uploaded some CN Tower from Toronto, the Taj Mahal, of course, and the Red Fort from India. Now I could set to go and train this model, but what I want to do is also provide what are called negative tags. You can see here the negative tags are basically images that don't have these tags, and they're going to be basically used to balance the model. So I uploaded Great Wall of China, the Sydney Opera House, Eiffel Tower, Times Square. Now I can say train. So I'm going to just click the quick training and not try to set up any advanced training at this point. So it's going to go off, examine the images that I've uploaded and the tags I've assigned to those images, and it's going to try to learn when to predict those things. Now you can see it came back and said that it has a 50% probability score, and it thinks it can do Toronto, Taj Mahal, Red Fort 100% as its expectation. So those are based on the images that I provided for it. So what we should probably do is test it, right? We should upload our own image that's not part of the training set and see if it can recognize some of those landmarks. So I click the quick test button and I can browse the local file and pick another image. So this is the Taj Mahal at night, so not similar to what I've uploaded in the past. And I've uploaded it, and now it's saying India 99.95% and Taj Mahal 97.6%. You can see there are the other tags there at lower percentages, but the top two are pretty accurate. So let's try another image. So this is a CN Tower picture taken through two buildings, and it's 99% Toronto and 77% CN Tower. That's pretty good. Let's try another image. I'm going to try Times Square here, which didn't have any tags, and see if it confuses it for anything. Now it does seem to think this is Toronto. It could be. There's a lot of buildings, but it doesn't have a high confidence in any of the towers, the Red Fort, or Taj Mahal, or anything like that. So that's not too wrong given how low the amount of data that we've given to it. So we can see an example here of the custom vision in action. With very few number of images, we're able to train this model, and it's great in some places and not so great in other places. But if we had more data, it could be more accurate. You can certainly train your own model depending on your own unique subject. So we're in the second to last section of the course here, and we're talking about natural language processing. The requirement says, describe features of natural language processing, which is abbreviated as NLP, workloads on Azure. Now this section of the exam actually includes three main topics. One will be the concepts around it, so the features and uses for a number of NLP scenarios. And then the second part is going to be talking specifically about how Microsoft Azure uses those. And the third section says identify considerations for conversational AI solutions. These are chatbots and the Azure Bot Service. This used to be its own section of the exam, but I guess it wasn't big enough, and so Microsoft has put this along with the natural language processing section. So let's talk about the use cases for natural language processing. Now, natural language processing is an interesting phrase. It basically means that a computer is able to understand either written or spoken natural human language. It understands English, it understands French, it understands Italian. Whatever the language is that you set that up for, the computer is able to understand and determine what your intention is. Some of the tools used for this would be something like key phrase extraction. So you can basically identify the main points of a document, and it understands the context of that. So I just created this sentence myself, but you can see on screen, when I was shoveling snow in my driveway earlier today, I cut my finger. It's a true story, actually. It wasn't a deep cut, and I'll be okay, but it was a bit painful, and snow isn't fun sometimes. The key phrase extraction, if I was to run it on that sentence, might come back talking about the key points being shoveling snow, cut my finger. I'll be okay, a bit painful, and snow isn't fun. So you can see that the computer is able to sort of understand the context, know what is the irrelevant parts, know what's the relevant parts, and can summarize this. Another type of NLP service is called entity recognition. Now, entity is basically an item within a document that is categorized, and it'll tell you the type and even the subtype if you ask it. Same sentence, and it'll identify that the entities mentioned are snow, driveway, and finger. The date would be earlier today, and the location is on my driveway. So this type of machine learning can understand those parts of the sentence. Again, we're giving an English example here, but you can certainly train it for your language. Another interesting feature of the same entity recognition is it can basically find the entity on Wikipedia, and so you can have links to Wikipedia from that service. The next concept of NLP is called sentiment analysis. Now, this is a pre-built machine learning model, and there's thing in sentiment is basically something is either positive or negative or neutral or something in between. So if I say I love cheese, then that is an extremely positive sentiment. If I say cheese is okay, it is a somewhat positive sentiment. If I don't like cheese, which I don't know why you wouldn't, that would be a negative sentiment, and something in between where it's neutral or there is no sentiment. So you can see a couple of examples where you can basically point your sentiment analysis at Twitter feed, at Facebook, at your reviews on Yelp, and it can determine whether there's a positive sentiment from the statement or a negative sentiment. The next thing about NLP is you can basically train it to build your own dictionary for terms in your industry. So if you do need to, if you're working in IT like we are, maybe there are certain terms that are specific to IT that it would need to understand the context of it. And so you can obviously develop your own model, and that could help you in other things. Another type of NLP is what we would consider to be speech recognition and speech synthesis. So speech recognition is the ability to detect and interpret human speech, and speech synthesis is the reverse. It's the ability to generate spoken output, and that is commonly called speech to text and text to speech. Now imagine, you've got someone like myself that can speak without much of an accent. Some people have different accents from different places, and the computer needs to be able to understand you no matter how much different your accent is. Lastly, when we're talking about human languages, we're talking about translation as well. Quite a common request where someone could be speaking in English and then the audio comes out in another language. In fact, you're listening to this course and you might have subtitles that are in English, and then the subtitles are also available in other languages. Now, Microsoft Azure specifically supports over 60 languages, and you might say, oh, I've seen this translation a couple of years ago. It's getting better all the time. So even the translation from 5 years ago, 2 years ago, till today is a big improvement. Translation understands the context of what's being said. So instead of having to deal with a literal translation all the time, which is what maybe used to happen, it does now understand that certain phrases have different to their literal translations. An example might be café da manhã, which in Portuguese is coffee of the morning, but it actually means breakfast. Even if you don't have coffee, café da manhã is breakfast. So translation is getting better, and your NLP service is what's going to help you with that. So the Microsoft Azure Cognitive Services for natural language processing are broken up into several services. To start, we have the text analytics service. So anything that has to do with analyzing the contents of text includes key phrase extraction, entity detection, and sentiment analysis is all covered by this service. It can detect not only the language, but when text has multiple languages, it can identify which is the predominant language. So if you include the phrase bonjour in an English text, it isn't going to confuse it to say that this is French. And if it can't determine the language, it's going to return NaN, which is an unknown value. Going on, it's also got the language understanding service, which is abbreviated as LUIS. And this is where it actually understands whether it's English or another language being passed to it. There are three core concepts of natural language understanding: utterances, entities, and intents. So the utterances are something that you say, like what time are you open till, when do you close, what time do you close. That is the entire range of inputs that your customers or whoever is speaking to your AI bot can say. Now, the artificial intelligence is going to then recognize what are the entities. So if you say, what time do you close, the artificial intelligence is going to then recognize what are the entities. So if you say, what time do you close today, then it's going to say time, it's going to say you, it's going to say it's going to try to understand the objects inside of that sentence. And then the last thing, and the most important thing, is the intent. And so all of those phrases that have to do with your hours of operation, you can say that many different ways, but ultimately all you're concerned with is the hours of operation. And so the response by the machine learning is going to pretty much be the same once it recognizes what your intent is. Sometimes it is possible for someone to say something to a machine learning algorithm and they don't have any intent. Like, what is the meaning of life? And so how is your algorithm going to respond to such a big question? How do you teach a dog to walk himself? These are maybe jokes, rhetorical statements, and so your language understanding is going to have to accommodate for these kind of nonsensical situations. So don't just trust that your users are going to say, what's your hours of operation and what products do you have and how can I contact you, but they're also going to say some silly things and your algorithm has to be able to handle that. Besides that, the language understanding, you also have speech services like text-to-speech, speech-to-text, the real-time translation between the audios, and one interesting thing is you can even get your custom voice model. They can train the algorithm based on a human voice, and then that algorithm will basically be able to simulate that voice. So let's say you don't have to no longer get your model to say every possible phrase, 1, 2, 3, 4. You train the model, and the model can then imitate that person no matter what you want it to say. That's very interesting. Finally, the last service is the text translation service. Again, you translate text between 70 languages it now supports. You can create machine learning models based on different terms. So for instance, if I was going to do text translation for my Microsoft Azure courses, I'm going to have to fill the custom dictionary full of terms such as Azure, machine learning, AI. These are computer-specific terms and not terms that everyday humans use. And again, I said like the translator services, the analytics service can detect the language, and so translator certainly can do that as well. So the last section of this course is talking about conversational AI. Now, conversational AI is basically not only understanding in a natural way. Now, we see this often with web chat bots, where you're having a conversation with a message or something that pops up on a website, and you know that it's not a human on the other end. We are also seeing this in limited fashion on the telephone, and certainly with all of our phones and home speaker systems and all of these personal digital assistants, you can have conversations with them as well. So Microsoft's calling this conversational AI, and it's based basically allowing a human like yourself to talk to a computer. Now, these are typically called agents. Sometimes they're called bots. So Microsoft Azure bots can operate over the web, through email, social media, and there is also the ability to chat with them by voice. This reminds me of a rather famous use case a couple of years ago where Google started to basically call restaurants to make reservations on behalf of users. So if you have a Google Android device and you say, Google, book me a reservation for tomorrow at this restaurant for 8 p.m., it will actually call it using a bot through the phone. And it's actually interesting because not many restaurants knew that they were talking to a bot. So it's like, hey, I'd like to make a reservation. Okay, what time? Okay, what's the name? So literally they were calling. Now, they did get a bit of flack because they weren't properly identifying themselves as being bots. And so I think right now they say, listen, you're talking to a bot. They've modified that. Let's look at some use cases for the various types of conversational AI. So the most common type is a web chat bot. So whether it's social media or appearing on your own website, it's basically a bot that you can write to and it can understand you and respond. These are very narrow AIs, and because you have to basically program these using the bot framework, it has a very limited scope of conversation. You have also the ability to add friendly conversation to it called chit chat. Chit chat is an interesting English phrase, but basically it means how you doing, what's the weather like where you are. It is sort of meaningless conversation, but sometimes chatbots can have that while they're asking you, how can I help you today? You can look at an example like Domino's is always one of the first companies to get into these leading edge technologies. And so you can use SMS to order from Domino's, or in this case, Microsoft Messenger, for instance. And so you can basically have a chat with the Domino's Messenger bot and order your pizza or reorder the last one, etc. Now, there are limited use cases where calling into a customer service line gets you into basically a computerized menu that understands speech. And so you can press 1 to continue, or you can just say English. Press 2 to do this, or you can just say check my balance, right? So it understands what you're saying and has some of those AI elements basically by understanding natural language and then being able to respond to you. And finally, we talked about personal digital assistants a lot in this course, but this is conversational AI. Being able to talk to your phone, your navigator, your car, and basically ask it a really simplistic question and having it respond to you is conversational AI. Microsoft does provide a number of tools to do this, and really the only two that we're going to cover are the Q&A Maker and the Bot Framework. We'll do that in the next video. So we'll wrap up this course talking about the various services within Azure that deal with conversational AI. The two of note are called Q&A Maker and the Azure Bot Service. Q&A Maker is sort of like a way to build a chatbot without any code. So you basically point your Q&A Maker at some sort of data, and it's going to build you a chatbot based on what it finds. A really cool demo would be to point your chatbot at your website, and then it scrapes the website looking for frequently asked questions and your hours of operation and things like that. It builds a knowledge base, and then when the customer comes to the chatbot and enters the search term, it goes to its knowledge base and sees if that intent is found and can give the result from that. You can also do this from formal FAQs that you have written, product manuals, other semi-structured data. It doesn't have to be sitting in a database, but they have to be able to interpret questions and answers from it. For instance, if you go to the Udemy support site, you can see the answers to questions are quite organized. They've got the question as the title, it's clickable, you can see the answer. So I can point the chatbot at this site, I think I will, and come up with an interesting result. Here's an example I found on the Microsoft website of user just can interact with it and it's just going to find the best answers. The other end of the spectrum is more of a customized bot called the Azure Bot Service. This is enterprise grade. You can think of all the sophistication of Azure, all the sophistication of cognitive services, and you can build that into a chatbot. And so you can be quite simple if you want, or you can start to add code. Again, you can think about examples such as UPS, where you can chat with UPS and it will actually send you back a graphic telling you when your package was delivered and the date and the time. It's sort of a very customized experience. So the Q&A Maker and the Azure Bot Service are the two main services that you need to know for this exam for conversational AI. Now obviously we can get a lot deeper into this. This is not meant to be a coding course, or the exam is not going to test you on that level of detail as well. So I have kept this very high level. Well, that's it. I want to thank you so much for being part of this course, an AI 900 Azure AI Fundamentals. I think that you are going to be ready to take this exam if this is what you would like to do. So go ahead on Microsoft's website and book the exam. Schedule it out for a few days with a little bit more studying, maybe watch some more of the videos. You'll be ready to go and take the exam. I really appreciate you being here. If you left a review, thank you